So today we have Wahaso with water harvesting solutions. Than Hansen is going to be the main presenter today. He is the vice president of sales for Wahaso. He has over 12 years of experience in the water harvesting industry, and he focuses on education, business development, and sales. He has a bachelor's of arts for international studies from Washington College, but also a master of science in industrial design from Pratt Institute. That will be the quick jot down for you. This is getting recorded, so we will have the ability for you guys to see this again later if you need any refreshers. But please use the questions in the chat and we will get those answered for you. But I will pass it off to Than and have him introduce Stuart a little also.
Great, thank you so much, Brian and Steve. So hi, everyone. Excuse me, I probably know some of you already, and it's good to present to you. Looking forward to hopefully meeting in person again sometime. But we're excited to be presenting an introduction to our systems and experience with water harvesting in Northern California. And I'm going to be working with Stuart on this, so I'll lead the slides he's going to read, but and discuss with you. But just so you know, there will be a few pages here and there where we take a break for questions. So we'll just pause a little bit just so you can do the Q&A answers in that respect. So I'll let Stuart take over and I'll start running the slides.
Thank you, Than. My name is Stuart Balin. I am the president as well as director of engineering for Water Harvesting Solutions. I've been doing this water treatment for about 40 years. We've been doing water harvesting as a company for the past 16 plus years. And what we're going to go through today, as I said, takes about 45 minutes, and we'll go through it and we'll talk about what is unique about Wahaso, along with some very basic information on water harvesting trends, but we're not going to spend a lot of time on that. We're going to talk about things I hope will be important to you. Then I see question one is after what you're going to.
Sorry, I was muted. Everyone, this
Hey,
is the start question.
Yeah, we'll start the first initial poll for you guys. So this is just to get a little bit of a background. So you guys should have a poll popping up in front of you right now, and you're just going to pick one of your answers. So yep, I know it's working. I got people picking it. Thank you, guys. So I'm just looking to see how many we have grabbed up. So Than, I think you can probably see it as it's populating, but it looks like we do have a good mix. So it does look like I'm aware and have past experience, but there are some people that are new to the technology also. Okay. Looks like we got about, I think I got most of the responses we're gonna get. Let me end this one real quick. Okay, so okay, so you're all set, Dan.
Great. Okay.
Okay. So I apologize. I've never done a presentation before where questions pop up and people get to answer. So they caught me by surprise, and I apologize for that.
And of course, I was off on the side a little bit, so that was my fault.
We've been around, as I said, for about 18 years. We do projects all over the United States, North America, and the Caribbean. We have had opportunities to do other projects outside the United States, but up until now, we've kind of looked the other way on those because we want to be able to service everything that we sell. So that's why we've concentrated in basically projects from Alaska to Florida, Texas, California, all over the United States, and then we've done projects in the Caribbean. We have some custom software that we've developed over time that help us quickly analyze a system and what is going to be required for us to help you help your clients on a proposal for a given system. What I'm saying is we do what's called scoping. We're going to talk a little bit about that, but we offer a free service where we'll do a fair amount of upfront engineering on a project to help figure out if it's viable and give the owner an opportunity to make an informed decision, that he's going to actually get some bang for his buck for spending money on water harvesting. Our systems are all skid mounted. I hate the word plug and play, but they are plug and play literally, because when we have multiple skids, we have a central control panel, which you're going to see more about this in a little bit, but it's basically cabled together, so the amount of field wiring and also plumbing is minimized. Our systems come with a standard 2-year warranty, and we offer longer warranties at an additional price. When it comes to gray water processing and some of our other customized systems, we have some proprietary equipment that we offer. And we're the only manufacturer that is NSF 350 and IATMO 324 third-party certified for water harvesting systems. At current, NSF 350 is strictly a gray water standard. IATMO 324 applies to all kinds of harvested water with the exception of black water. Next slide, please. When I look at what water harvesting is, it's the collection, cleaning, storage, and reuse from on-site sources to reduce the consumption of municipal potable water. What does that mean? What it means is that some people in my industry think that we should be creating potable water from, say, rainwater. It's not a great idea in my mind. I think we are much further ahead to look at all of the drinking quality water that we waste on non-potable applications, such as toilet flushing, irrigation, cooling towers, vehicle wash, and the like. So we want to offset those uses with harvested water, which in turn makes more municipal potable water available for bathing and human consumption. Make sense? Thank you. This shows a list of the typical water sources that are available, and sometimes on a given project there might be more than one of these opportunities for capture and treatment and reuse. So we look at these different types of sources and come up with an option that makes the most economic sense. But I will tell you that those systems that use multiple sources for on the supply side and multiple reuses on the demand side, those are the best projects. They usually make the most economic sense, and they're not stage. These are some other opportunities for harvesting sources. Steam condensate is a good one. Water from air handling units also is excellent. Sometimes we can recover vehicle wash water and site wash down water. In the LA area, we have done a number of projects where we captured what they call dry weather flow, which means that that the water flowing in the LA canal system, that water is coming from runoff of properties that is not necessarily from rain. It could be from irrigation systems, it could be from air conditioning. There's a number of places, but they found in Los Angeles that even during the driest months, there's still what they call dry weather flow, and it can be significant. We've done several large parks in the LA area where we've captured several million gallons of water per day, and we reuse it for irrigation in those projects. Next, please. When we look at how you can reuse the water that's acceptable by public health and also by communities and the regulatory groups, these are the common things that you can reuse harvested water for. And if you note, all of them basically could be provided by non-potable source water, which then again makes potable water, more potable water available for other uses by offsetting these demands. So irrigation, obviously no brainer. Toilet flushing is Practical only if you're doing a new construction project, because you have to run different types of piping to be able to do that. So on a retrofit, maybe, but existing building, probably not, toilet flushing is not going to be an option. Cooling tower makeup is probably our #1 biggest reuse. Cooling towers use literally tons of water a day, and we have many applications where we're collecting water for cooling tower makeup, and we treat the water, soften it as necessary, filter it so that it makes very high quality water for use with the cooling towers. We do a fair amount of wash down applications. We've done some train washes, as well as some very large multi-lane car washes. And then finally, the last common application for harvested water is laundry. It can be used in the laundry cycle. We've done some boiler makeup projects, swimming pools and fountains, not so well. I say swimming pools, not so much, but fountains. We do a fair number of fountains, and the key here is you have to make sure that the water is totally sanitary, because people put their hands in the water and then their hands in their mouth, so that water better be bacteria free, and we work to ensure that. Our goals when we design a system is to reduce the volume of municipal water that's being used for non-potable applications. We want to customize, well, we are willing to customize each system, even though we make standard products, how we package those and how we put them together, we'll customize that to best fit the building and the space available. We want to ensure that the water is safe while it's being stored and while it's being reused, so that if there is unintended human contact with that water, nobody's going to get sick. Hold on a second, I got to figure out how to get rid of this.
So Dan, why don't you move to the next slide, because there was a question.
Okay. Yeah, so here, everybody, is the second question. I think Stuart got dropped off, unfortunately, but for those of you with experience pursuing water harvesting, what percentage of those projects have actually formally evaluated it? And there's
And there you guys go.
choice.
It's gonna pop it up. It's actually showing both questions for this one, Dan, because they kind of build off of each other. So you guys should have a
Okay.
poll in front of you right now if you guys want to shoot your answers there.
And she was supposed to be there walking and like looking what
This one?
showing me
I see.
Yeah.
Okay.
So it's basically, first question is, have you had experience, designing, in the planning phase, and then how many of them actually made it through past that? And it looks like we're in that really low range, Dan. We're in the 0 to 25 is almost everyone. And then you have a couple people that do have 25 to 50% also. And
Okay. Yep.
so it looks like we're still getting in a couple answers. Just give it one more second. Okay, you're all set, Dan.
Okay, great. I think.
Sorry
Stuart
about
is
that.
second.
I was so
Yeah.
good at getting rid of the call, I got rid of myself.
Okay, he's back. Okay,
All right,
so
back.
And close the window, the poll window.
it is closed.
Oh, okay.
Go ahead, Stuart, sorry.
Okay. When we work with clients, what we do is there are several different people that we meet along the way. We usually start with architects, owners, and developers. That's a very common place to start. And the owner wants to know whether it
Too
is
often, too.
practical.
But yeah, like I said, the price point at 2.5 is kind of off.
Brian, mute yourself.
Thank you. So we'll work with architects and owners and developers, and we will provide you at no cost a very significant an order of magnitude of how much that system would cost to buy. If you provide us the water and sewer rates, we'll give you a return on investment. And there's quite a bit of additional information depending upon if it's a rainwater, stormwater, or gray water project. The information is tailored. We have a 2-page questionnaire that we give you to fill out. It gives us the parameters that we need to do an analysis. And again, our clients have been very pleased with the quality of the type of report that you get back. So hopefully after the analysis is done, the owner can make an informed decision that he wants to do water harvesting, and he'll get with an MEP engineer, and we will work with them to help design an actual system and help develop specifications for that project, excuse me. And we can provide AutoCAD and Revit importable files to the engineers to use with their designs. And we act as a consultant on many projects. And again, oftentimes we will not charge for a lot of this engineering. All that we ask is that we will be the basis of design in the spec package when it goes out. It goes out to bid. We bid all the contractors, and hopefully we get the contractors that we're working with are awarded the project, and then we will work with them closely and give them all of the technical support that they need. We will give them an installation manual that's illustrated with photographs. We will provide site visits and whatever is needed to get the job installed correctly the first time. Some of the things that we do, as I might have mentioned earlier, is our skids are modularized, they're pre-plumbed, they're pre-wired. If we have multiple skids, we use UL approved multi-pin connector cables that make installation in the field much quicker. We test each system before we ship it, so we don't have to scratch our heads and wonder if it ever worked. We know that it worked when we shipped it. So usually if there's an issue in the field, it's usually something pretty simple, and then we can get through that. We will help with the on-site startup of the system, which includes oftentimes some testing with laboratories to make sure that the system is producing the quality of water that is required by the local public health officials. We will do the commissioning of the system. We provide an O&M manual. We will train the operating staff. We offer service contracts. So we find that is a much better approach than when we started out 18 years ago, and we would sell a system and then we would never hear from the people again. And then we find out that they had a problem, they didn't call us, and they turned it off. So our systems are much higher quality these days, and we like to be in touch with the owner to make sure on an ongoing basis that the system is working and they're getting the benefits of the investment that they made in water harvesting. Next, please. So I'm not going to read this slide. You can see it for yourself, but this is just typical of the different sources of water that might be available. And with that scoping form that I mentioned earlier, it helps the owner and the design people think about other options that they might not have thought about. And then we also will look at different options to reuse that water. So we want to maximize the amount of water that's available for reuse. That's our goal.
So I'm going to jump in here. So we wanted to know, there are a lot of contractors and a lot of engineers on here. We wanted to get a sense, Osborne Company is the new representative in California and Nevada and Hawaii. We know what percentage of the projects are actually being mandated and what percentage is more of the pursuit of harvesting for its own benefit. And so, Brian, are you there?
Yeah, I got you launched up.
Okay, perfect.
I already got an answer in, so people are in that 0 to 25. So I'm assuming that that's actually landing a lot in the 0 side. And then you have a couple people that are 25 to 50.
I would assume a good percentage of projects come with a mandate. So that's what we were thinking.
Just waiting for yep. So we got the end of the poll, so you're good. And,
okay, I think we can move
so
on.
you're all good to move on.
This just shows some of the information that we provide in the analysis report that we provide to you. We look at the top line, how much supply is available, what's the total demand, and the like. Okay, we also have the ability to stormwater and rainwater projects. If we know what the zip code is of the property, we can calculate the point of diminishing returns where you get the biggest bang for your buck, or in other words, where's the best point to start looking at how much storage you should have, as opposed to just taking a wild guess. What this chart shows that excuse me, that if you go from 30 to 35,000 gallons, your increase, the curve flattens out. So the amount of actual additional water savings starts to drop, and it drops significantly. So it becomes the point at which, you should start looking at. Now, that doesn't mean you have to be at that point, but it does show you that if you make, if your client says, I only have room for a 20,000 gallon cistern, they're at least going to see that the difference is about 5% differential, or about 25,000 gallon differential in making that trade-off. But it at least gives them some empirical data. Next. When we look at the different types of water that's available, this is kind of an important slide. There's different rules that apply to different types of source water. And for example, rainwater has a lot less restrictions than gray water. Gray water has a restriction by National Plumbing Code that you have to take whatever raw gray water you haven't used and send it to the sanitary sewer once every 24 hours. So if you can only hold raw gray water for 24 hours, because after that, bacterial growth and other factors cause that water to degrade further, and it starts to resemble black water over a period of time. So, it used to be clients would say, well, why would I want to harvest gray water if I can only hold it for 24 hours? Well, the answer is that once you treat it with an on-site treated system, such as Wahaso's, all of those raw water categories don't apply anymore, and that water is reclassified as on-site treated non-potable water. So it's kind of an important concept that you want to understand, that with water sources, there's different rules about how long you can hold them and what you need to do about it. And then, but once you treat it, those rules go away, and now there's a new set of rules, that's been codified about what you can do with that treated water, which is now all on-site treated, not potable water, regardless of where it came from. So we treat it to a uniform state and a very high quality level of treatment, and then you can reuse that water for different approved reuse applications. And we've already discussed most of those approved reuse applications. Okay, now we're going to talk about the different parts of a harvesting system. And shown here are 3 different types of pre-filters. We use all of these, and there's a few other pre-filters that also can be used, but these are the most common ones. And pre-filtration is very important, and a lot of times people try and skip this step. And when I first started doing water harvesting systems seriously about 18 years ago, I had an engineer talk me out of doing a pre-filter because it was just too inconvenient. And as a consequence, what happens is that your downstream storage cistern gets full of, I'm going to call it stuff. That's a technical term, stuff. And it starts to, cause problems. It can promote bacterial growth. There's, sediment and sludge buildup, and it causes a lot of headaches. And if you think about it, it's a lot easier to deal with these types of contaminants before they get into your storage, because once it's in the storage, everything that goes in after is going to be contaminated by what's already there. So pre-filtration is really an important step, should not be bypassed, and depending upon the flow characteristics and the source water, etc., we would recommend the correct type of pre-filtration. Next, please. There's a wide range of storage options. And the first question that needs to be asked is, do you want to store your water above grade or below grade? and how much of it do you have to store. In a lot of situations, especially if it's a stormwater, rainwater stormwater application, there might be some local regulations for detention and release on the property to help protect the municipal stormwater treatment system, because it can get overwhelmed during a deluge. So they've passed laws to say it on your property for the first 1 inch of rainfall and meter it back out over 48 hours or whatever the regulation says. So we take that into account as well. And these are just different types of storage. A lot of times, most of the time, I would say that our storage is going to be below grade. We're storing a lot of water, especially with rainwater and stormwater applications. It doesn't rain every day, so you need to have enough storage to small, because most of the gray water supply comes from showers and bathing, and we hope that people take a shower every day. Most people do, so you get replenishment every day, so you don't need to worry about storing large volumes because it's replenished on a daily basis. So concrete vaults, very popular, very easy to install. We used to do a lot of fiberglass tanks, but not so much because they're expensive in comparison to other opportunities of storage. And then for indoor storage, typically we're doing that with tanks. Those are popular with some clients that want to advertise that they're doing water harvesting. If your cistern is underground, it may not be obvious to people driving by. Want to be green, so those steel tanks can be painted with the company logo on them, and they're very popular again for clients that want to brag or tell people they're doing water harvesting. Next.
So let's get this question in, and then Stuart, I think this is the point where there's a couple of questions where we're going to save them to the end, but they seem to be relevant. So if the engineers and contractors on here, Brian, can you run the poll?
Yep.
To get the sense of.
And
But
there we go. So here's the poll. Despite whether you have past experience or not, do you see water harvesting as applicable to any projects in the next, time frame?
I have to wonder if our heavy rain events are having a positive effect on the technology or a negative effect. Well, while they're answering that, Stuart, there's a question for Kevin Luoma. Kevin, I hope I get your last name right. Do you have standard installation details with cistern, filtration system, and pump packages that we can use?
Absolutely. Yes.
Okay. So maybe we can follow up with that specifically, Kevin. And then Brian Hagman wanted to know if commercial toilets, or because commercial toilets aerosolize water when they flush, I'm surprised that toilet flushing water does have to be potable water quality.
It does not.
Okay.
Toilet flushing is an approved application in the state of California. Also in the new California SB 966 regulation that's coming out sometime. It's supposed to come out already, but things don't move very fast in the California legislature. That is an approved reuse. There are some sanitation requirements that are necessary to ensure that you are absolutely correct that atomized water from toilet flushing, that water has to be bacteria free. Our system, and approved systems have to comply with that, and we do.
Brian has one more question about irrigation. Is it always subsurface drip type?
Okay, if you're doing a subsurface drip irrigation system, most jurisdictions will let you actually use raw gray water with no treatment and no sanitation. We find that when we do those types of applications, even though the only requirement is that you dump whatever you haven't used to a sanitary sewer once every 24 hours. What we found is some treatment is required because there's chunks of stuff in that raw gray water, and that can plug up the emitters on the subsurface irrigation system. So a certain level of filtration is recommended. And we also offer a product that's made in Orange County, California, called Cooperdine, that is a odor killer. And sometimes when you do drip irrigation with raw gray water, people find that in the area where that's being done, it can smell. So there is a additive that we can provide that will kill the odor.
Okay. I think we're going to push on questions to the end, which includes our little Q&A. There'll be a couple more towards the end, but that's it. So you're free and clear to go ahead. Let's do it.
Okay, I wanted to talk about our we make systems for a wide range of clients. We have a system that we offer this for somebody who wants to do something, but they don't have a big budget, and they also don't have a lot of water to collect. But we have a small irrigation system that's a package system that we provide, and then we also provide full-blown rainwater harvesting systems for toilet flushing. We have stormwater systems, and we have gray water systems. We also have our ultrafilter based system. And this system was developed at the strong encouragement of LADBS. They encouraged us many years ago when we started doing projects in Los Angeles that we should have a system that was third-party certified. Part of third-party certification isn't just that you meet a rigorous testing protocol. It also means that it has to be very robust and be able to operate independently without much maintenance or operator involvement. And not to digress too far, but I did have a system that I came out with about 10 years ago, and it did meet all of the thresholds for gray water standard for NSF. However, it took way too much hand holding, and you needed a really good operator to keep the thing going, and it was just too problematic. So instead, I developed, with the help of some engineers from 3M, who actually now work for Wahaso, a very robust system that uses ultrafiltration. And what's unique about ultrafiltration is it filters down to 0.02 microns. A micron is about the diameter of a human hair. So we're filtering down to 2/100ths of the diameter of a human hair. And that means that just with the membranes itself, without any other sanitizing added to it, the membranes will filter out almost all bacteria, viruses, and large pathogens like Legionella, Giardia, and the like. So regulators really like that because they know that the water coming through this system is going to be bacteria-free, pathogen-free. And in particular, they like it for cooling towers around the country because regulators, when I say regulators, I'm usually talking health department people, are very concerned about Legionella in cooling towers. So this system has proven to be very successful at helping to keep these systems free from E. coli, other bacteria, etc. The system, when we tested it, to go back to the robustness, is we ran it 11 hours a day, 5 days a week for 6 months. And we ran about 3 million gallons of gray water through the system during the testing. And we had exactly 0 unplanned shutdowns. That was amazing to all of us. We were real happy to see that. In other words, the system is very robust. I'm not going to say it's bulletproof, but there's a minimal number of things that can cause an upset condition, and the system just ran and ran and ran. That the other thing, besides the durability and uptime, is what happens when a system is shut down for the building's not being used. It might be in a college dorm and it's spring break. Remember what I told you earlier is that, to say raw gray water, after 24 hours, it could start degrading into black water. So we have some proprietary things that we've built into our system that if the system hasn't produced or processed a single gallon of water in a period of time, which we set typically to 18 hours, that means the operator forgot to shut the system down. He walked away, thought he was done. We will do it for him automatically through software, and we will automatically backwash the system, purge all of the gray water out of it, and then it's sitting in standby mode. And all they need to do when they come back to go to the normal condition is press resume button on the touchscreen. Other systems that are out there, you can't start up a system just by pushing a button. Sometimes there's a lot of things you need to do to get the system prepared to restart. So that was also part of some of the patents that we got on the development of this system. Next slide. This particular system is excellent at removing turbidity. Turbidity being the cloudiness or clarity of the water. You can see in slides 1 and 2. We found that just regardless of what the influent turbidity is, the effluent turbidity is almost always between 0.1 and 0.3 NTUs, which is the optical measurement units. And when we were running our system, the testing facility, which happened to be IATMO's test facility in Ontario, California, they wanted to see what would happen if they ran charcoal black, dirty, opaque water through it. And it was 1,000 NTUs, which is the biggest that they could measure with their device. And it still came out at 0.3 NTUs. The water came in black, came out crystal clear. So it's very cool technology, and we're happy that that's our standard. Next slide, please. This is a chart that shows the difference between IATMO and NSF and what Wahaso actually does. I will tell you right now that NSF 350 standard is undergoing a major change. The reason for that is NSF came out about 20 years ago. And what happened was it was a gray water standard only, and regulators would come and say, I want a rainwater system or a stormwater system that's NSF 350. We would have to say, sorry, can't do that because NSF won't certify anything that isn't a gray water system. So then they said, okay, well, make it perform to the same levels that it would be as if it was gray water. IATMO came around about 5 years ago and said, we're going to come out with a standard that applies to all kinds of water, which they did. And the biggest difference between these two standards is if you look under E. coli, you'll see under NSF 350 required value is it does give you some targets that you must attain. Okay, you have to have less than 10 colonies per 100 milliliters on average. Well, regulators decided they didn't like that. They prefer log reduction methodology. So they instituted, IATMO went along and they said everything, whether it's E. coli, virus or bacteria, viruses, or pathogens, it's got to be better than 4 log reduction. We at Wahaso, if you look at the right, we're typically a 7 log reduction, which is a 1/1,000,000th reduction versus 1/10,000th reduction. Okay. So NSF right now, because we're stopping to use that standard, they're revamping their standard right now to go and switch it to log reduction. They probably will switch over and also undertake requirements for water other than gray water, but I don't know that for a fact yet. So we'll have to wait and see what they come out with. They don't move very fast, but we'll see something. So anyway, long story short is governmental agencies are looking to third-party certifiers to help ensure that the systems that they allow in their jurisdictions are safe for the general population. I'm not going to spend a lot of time on this slide. This is a P&ID of a gray water collection system. It looks really, really complicated, and I will tell you that it's really, really not. Basically, you have a collection tank and a way to completely drain that tank. You have your treatment system, your first and second treatment. You have all of these systems, whether they are IATMO or NSF certified, have to have UV sterilization at a minimum. So all of them do include UV sterilization. And then if you're doing toilet flushing, regulators in many jurisdictions require that you add chlorine as a tracer because they want to be able to take a grab sample at a toilet and see that there's some residual chlorine available. And as long as there is, they get warm and fuzzies in their tummy, and they're happy that the system is working properly if they see that. So that was that. This is a typical picture of the smallest unit that we make is a 35 gallon a minute system. That's a lot of gray water per day. If you think about it, that's typically 35,000 gallons or more per day that can be processed. We make systems up to 500 GPM. We can go larger, but right now that's the biggest that we make. And the footprint is really, really small. It is roughly, and there's only one view here, but it's roughly 48 by 64 for the skid size. That's a really small footprint for a lot of production output. And
Dan,
then five,
the next slide has the other skids.
yeah.
Sorry?
Slide, yeah.
Anyway,
Yeah.
stay on this slide just for a second.
Okay.
Go back to that one. There are just 5 connections. Again, the system is pre-piped, pre-plumbed, and pre-wired, so it's pretty much set in place. Bring your electricity over, bring your plumbing connections, of which you see the 5 there, and you're ready to go. Next, please. These show some of the different units that we make, just showing you that we make larger sizes. Next slide, please. With gray water, we use those system, the ultrafilter system with stormwater and rainwater in certain applications. But when we use it with gray water, we find that even though there is a clean water backwash that occurs periodically, it's a backwash of about 50 to 100 gallons in 30 to 60 seconds. And we do that every several thousand gallons, depending upon the loading. And that's usually good enough to keep the system clean. What happens is that if the membranes aren't clean, the water quality remains the same. However, the throughput or the amount of water that you can get through the system starts to decline. So after we backwash it with clean water and it's automatic, we want to see it revert back to its full production rate. After a period of time, the clean water backwash, sometimes it loses its effectiveness and we need to do a chemical clean. And we have a skid that we offer that automatically does that. It automatically mixes up a high pH solution. It recirculates it through the ultrafilter system for 5 minutes. It disposes of that water. And then we run a clean water rinse to get rid of any chemicals remaining in the ultrafilter system, and it reverts back to normal operation. Again, it's all automatic and the operator doesn't have to do anything. I just want to make you aware that that exists. We have a wide range of UV sterilizers. This is one system, but we have many more. We have them up to, typically 500 GPM is the biggest we go with. Some of them come with automatic wipers. We customize these to meet the application. We are required by IAPMO and NSF to monitor key parameters of the harvesting system. And those can usually include turbidity, pH, and the UV transmission data of how much radiation is being sent. And turbidity is our best indicator that the system is working properly, and we want to see that is below 0.3. We are usually, as I said, we're allowed to go up to 2.0, but we want to stay well below that. So when our systems run, they're typically less than 0.3 NTUs, and sometimes they're down to 0.01. Just depends on what we're doing. Next. This just shows some. I'm going to take through this real quickly here. This is a package system, as I talked about, for the small guy who wants to do something good. We do a lot of these for Whole Foods grocery stores. There's a cistern, and there's a wet box and pump. It's a package system, and we provide the entire thing. And they're typically a $50,000 or less investment in a system. And then we have our larger rainwater systems. These are typically put in buildings and used for toilet flushing. We have a number of those in the Bay Area. You're going too fast now. But you can see from this picture that it's a package system, and it's already pre-wired, pre-plumbed. You set it in place. You bring electrical power to one place in the panel. All the power is distributed. Everything's taken care of and very easy to start up. Okay, now you can go. Go to the next slide. This is a condensate system for air handling units. And we have a package system that we created because a number of people over time asked for them, so it became a standard product. But you can collect typically 2 to 3 gallons per minute from an air handling unit times 1,440 minutes in a day. That can be a sizable volume of water. That condensate water is usually quite clean and can be sent up to the cooling towers. Is typically what we do with it. Next, all of our systems are touchscreen interface. We custom program for each project. We have these systems that can interface with any building automation system. Common ones are Modbus and BACnet, but we can do anybody's and have a way to interact so that the building automation system can interact with our system as well. All of our control panels are UL. Our typical panels start out at NEMA 12, which is, not waterproof, but if you get some intermittent splash on it, it's not going to cause a problem. NEMA 3R for our outdoor enclosures, and we occasionally get a request for NEMA 4X. Again, yeah, you can go for it. This is a picture at the left. Actually, look at the right. At the junction box, when we have multiple skids, we pre-wire these systems and connect all of the devices at the junction box in this terminal strip. And then there's a cable that comes out, and then at the control panel, main control panel at the other end, there's either an 8-pin or a 10-pin cable, and you just click it in and turn it. And we have made it so that all 8-pin connectors are 115 volts, and all 24 volt DC signals, whether they're analog or pulse, those are 10-pin connectors. So you can't blow something up by hooking up 115 volts to a 24 volt cable. So the cables are numbered. Hopefully people will hook up the right ones to the right place. Next. This is a project that we did in Orange Memorial Park in South San Francisco, not far from the airport. It's an irrigation system, 200 gallons a minute process rate, and they're using it to irrigate the park. They wanted a third-party system. And another project, this shows it in our shop being fabricated. There's a 901 Cherry. It's a Google property, and we're taking rainwater and stormwater and reusing it for multiple applications: toilet flushing, irrigation, and cooling towers. And Park Towers was another project. It's an older one. I can tell it's an older one because the skids are white. We switched to tan because the white ones just look, the static electricity brings all the dirt onto them and they look terrible. So we went to tan and it doesn't show up at all. This is another small system that we put in at the Mexican Museum. 270 Brannan, again, another older project that we did a number of years ago. But again, it's been running for a long time and no major issues. One of the things I wanted to talk to you about, because it may be a question, Brian, is this a good time to talk about SF Department of Public Health?
Yeah, I think we're doing good.
Okay. We've had over time, Wahaso has had some challenges. Actually, Osborne Company has been terrifically helpful in getting us to get this resolved, in that they required a biological digestive system as part of the treatment methodology. And we have been we had been discussing is the polite word, with SFPUH for a number of years. I should say SFPUC, that there's more than one way to meet the requirement, and that there are ways to achieve the BOD result that they are looking for without using a biological method. And I've been having this discussion with them for more than 10 years. When the California State Board came out with SB 966, the water boards, came out with it, and Wahaso and its ultrafilter system has been deemed and acknowledged to be a SB 966 compliant system. Well, I asked SFPUC if they would, are going to follow that, and they said, well, we want to see more. So long story short is where we're at right now is we have a manufacturing partner in a company called Algae Wheel that makes a really cool biological digestive system that we incorporate and use with our system. And they actually use our system as well with their equipment in certain instances because they don't need to have clarifiers when they use our ultrafilters. So it saves a lot of floor space. Algae Wheel with Wahaso meets all of the 12C requirements from the San Francisco Department of Public Health and SFPUC. We don't have any installations in the city of San Francisco that is just the new. I have an old one that was approved. Our older system was approved, but our new system was not. So they have agreed and been convinced that, yeah, most likely the Wahaso ultrafilter system by itself without the Algae Wheel will conform to 12C, but they want to see proof. So we are doing a project right now in Los Angeles. It's a high-rise apartment building that has laundry and bathing showers. The problem is to create enough BOD, you really need laundry because the requirement is that you're below 25 parts per million of BOD. Well, a lot of places don't even generate that much. So if you did nothing, you would be compliant. But SFPUC said, well, we want you to prove it. We will let you use that. The project is called Koreatown in Los Angeles, as if it was in San Francisco. And we are going to be sending them the third-party certified test results. And if our BOD is less than 25, they will accept our system without having to use the Algae Wheel addition. That will save a lot of floor space and cost. And how long will this take? I don't think it's going to take that long. We're supposed to be starting up the Koreatown system in May, and we need to get some residents in the building to create gray water, so we have something to test with. So we expect that by July we should have test results back, and Osborne will of course make everyone aware that the Wahaso system has passed with flying colors, because we know it works, because we've never had more than 5 parts per million of BOD on all the systems that we have out there currently. It's just that we don't have one in San Francisco. They want to see a test, third-party test. As long as that test shows that we are, we finally have crossed that bridge, and that's about all I have to say about that.
So a couple more questions at the end, everyone. This is just inquiring whether you knew about Wahaso before this event and Osborne's invitation.
Yeah, so I have that one out. So it looks like we are definitely introducing you to a large percentage of the group. So that's always a good thing. We do have some members that are in here that have seen you guys before. The next set of poll questions are just kind of a ranking so that we understand what you guys see on the engineering side has seen important. So it's kind of a 1 to 10 scale. It's going to list all 5 of these as one question or one set of polls. So just scroll through it and we'll talk about some questions that came up while this is going through. So I'm going to launch this for you guys, but it's just to make sure that we're targeting on the right things you guys need access to make sure that it's on there. One question I had come through, Than, by the way, is that I was talking to and answering while you guys were on. I know in larger gray water systems, you know, the reclaimed water systems, most likely the treated water is being stored in some type of, you know, either basin or something to that effect. And then it's going to require a booster pump to then repressurize that water. On the smaller systems that are like, you know, the one you showed that had the 2 filters in it, you know, like we're talking about like supermarkets and things like them. Do those have the pumps included that would then repressurize it to deliver it? Or are we
Yeah,
still looking at a booster?
we provide all of the pumps from the transfer from the raw gray water tank through our system, ultraviolet, excuse me, recirculation, and also repressurization for reuse.
Okay, so it was a little
That's
misleading on that, Kevin, when I answered that. But
Yeah, we provide all of the equipment.
And Brian, that example, those NEMA enclosure-based units, those were small rainwater systems, but like Stuart said, if it were gray water, it would be us providing it.
okay,
So, and then here's the last question. Are you ready for that, or?
let me just see if people are definitely making it through. Yep, so we're good on that. So we're just going to throw up a last one. Hold on, just pulling the results from that one. So I have it. And
While you're running that, Stuart, there is another question from Brian at Mazzetti. Does adding the algae wheel to the UF open the door to black water treatment for subsurface drip irrigation?
Sorry, I was on mute. The answer to that is absolutely yes. With one of the reasons why we hooked up originally with algae on black water systems, so so now we can provide black water systems as well.
Yeah. And if there are other questions, we're happy to answer them. We understand it's we're at the end here. Really appreciate it. We're really excited about what this presentation gives us in our new relationship with Osborne, as Stuart was saying.
I think the main point for those 70% of the 30% of saying yes is that we want to offer, that if we want to have a dedicated meeting on something to reach out to us, and we can carry this conversation forward. We figured the San Francisco Department of Health matter might be something where a number of you are working in San Francisco. That's a conversation we can definitely carry forward.
Yep.
But there is one last question, and I think we're running out of time. But from Kevin, do you know the code section for 24-hour gray water storage? We use UPC 2018 in Hawaii. I don't know if anyone knows the code section for 24-hour gray water in California.
Yeah, we may have to reply back to Kevin. I'll shoot it out to you, Kevin. The actual code section for it. I don't know if Stan or Stuart have that off the top of their head.
No.
So we'll get the code section for you, and we'll send that out to you, Kevin.
Yeah.
Okay.
It's interesting that you asked that question, because I asked that question about a month ago to LADBS, because they didn't specifically say, and they were a little embarrassed, and they did finally find a place where it does say 24 hours, but they are going to be making an effort. It's part of the National Plumbing Code, and for gray water usage, it's pretty much universally understood that it's 24 hours, but I agree with you that it would be nice to actually be able to cite a place where it says that.
Okay, well, we're just past 1 o'clock, 1:01.
Yeah.
So why don't we call it? If anyone wants to follow up, you have our contact, Brian's contact. We can move forward from there with direct questions and answers.
Yeah, so thank you guys for those that attended. As you can see, right at 1, we start losing people. If you guys have the questions, you have my direct email right now because I'm the one that sent everything out.
So you're more than welcome to send anything directly to me. If we can't get it answered, we'll pull in Fan and Wahaso, probably Stuart too. But if you guys have specific projects you'd want to reach out to us about that are in the development or design phase, we can also help with that. So please reach out to us. Thank you all for attending. Thank you, Fan and Stuart, for doing the introduction for us today.
Thank you all.
Absolutely.
Thank you.
Thanks, everyone.
All right, bye.
Bye-bye.
Bye.